So for our third installment, part 3, and this will be the final part in analyzing round parts, I'll show you yet one more way, the most efficient way that is, to analyze axisymmetric parts with just static analysis. And that is to take advantage of a new feature in SolidWorks Simulation Professional called 2D simplification. 2D simplification was introduced in Simulation 2011 and is available in the Simulation Professional package. When we have purely axisymmetric parts like this one, instead of cutting it into a 90-degree or even a 10-degree wedge, we can actually analyze just a single planar cross-section. And the way this is done is, first you need to have a reference axis in the part, and I've gone ahead and created that in advance, and then I just want to isolate or identify a reference plane that would be convenient for our analysis. The front plane would be a convenient choice here. I'll create a new study, and I'm going to call this one 2D planar. It's a static study, but down at the bottom of the options, I'll choose the option Use 2D Simplification. If you do not have Simulation Professional or higher, you will not have this option. In the 2D Simplification options, I can choose either a plane stress, plane strain, or axisymmetric option. In this case, axisymmetric is the right choice. We choose our section plane, and we choose the axis of symmetry. SolidWorks then reduces the model to a 2D cross-section. We can now apply our loads, restraints, and any other setup parameters of the analysis to this 2D cross-section. Let's apply our external pressure load. Here we're applying to edges, not faces. So I'll just work my way around to these internal edges, which represent the internal faces of the revolved part. Once again, entering 1000 psi. For our fixtures, I'll use a roller slider restraint on this end edge. The roller slider, since this is just a 2D model, is going to restrict just the X direction. We don't need to restrain the Y direction, because the part is allowed to expand radially. The material has already mapped over from the SolidWorks model, consistent with the previous studies, AISI 304. We're now ready to create a mesh. Now the benefit of the 2D axisymmetry is that we can use a much finer mesh since it's just a 2D cross-section. Therefore we can get much more accurate results with less compute time. The model runs in a matter of just a few seconds. And we can see how the model is expanding radially. And we can see that the maximum stresses are in the neighborhood of 50 megapascals, which is consistent with what we found from Lesson 2 with our 90-degree quarter model. Now the nice thing about the axisymmetric 2D simplification is that we do have the option of showing the results on a 3D plot. So when I right-click and choose the Show 3D Plot option, by default it puts in a 330-degree segment. So that way we can see what the model would look like in its fully revolved state with a little bit of a section cut taken out. And that is modifiable just by right-clicking on the plot and choosing Edit Definition. We can make that a 180-degree plot, for example. So here we can see, using the 2D simplification option lets us take that axisymmetric geometry and solve it with a much higher resolution mesh much faster. So that is definitely the way to go for analyzing static analysis of axisymmetric or round parts. So that's taken us through a 3-part series of analyzing a full model, using symmetry, and then finally using the 2D simplification. I hope this has been helpful for you.